The integration of artificial intelligence into open-source intelligence operations has revolutionized how investigators, cybersecurity professionals, and intelligence analysts gather and analyze publicly available information, transforming what was once a time-consuming manual process into a sophisticated AI-driven discipline capable of uncovering hidden connections and extracting actionable insights from vast data landscapes. Modern AI-powered OSINT tools leverage machine learning algorithms to automate the collection and preliminary analysis of data from diverse sources including social media platforms, news archives, public records, satellite imagery, and the broader surface, deep and dark web, dramatically increasing both the speed and scale of intelligence gathering while reducing human error and oversight. Natural language processing enables these systems to pass through millions of text documents in multiple languages, identifying relevant information, extracting entities like names and locations, detecting sentiment shifts, and even flagging potential deception patterns in written content, capabilities particularly valuable for monitoring extremist forums, tracking disinformation campaigns, or investigating transnational criminal networks. Computer vision algorithms extend this capability to visual data, allowing AI systems to analyze photographs and videos for identifiable landmarks. Facial recognition, where ethically and legally permissible, object detection, and even geolocation by matching architectural features or vegetation against known databases, turning ordinary social media posts into valuable intelligence leads. Perhaps most significantly, AI excels at correlation analysis, automatically connecting disparate data points across sources that human investigators might never think to link. Recognizing that a username on a hacking forum matches an email address in a breached database, which in turn connects to a LinkedIn profile revealing employment at a critical infrastructure facility. This pattern recognition capability proves invaluable for threat intelligence, where AI systems can monitor underground markets for mentions of specific vulnerabilities or corporate names, alerting security teams to potential targeting before attacks occur. The application of machine learning to social media intelligence, or SOCMINT, demonstrates AI's transformative impact on OSINT, with algorithms capable of mapping influence networks by analyzing follower patterns, post timing, and engagement metrics to identify bot networks or coordinated inauthentic behavior. These systems can detect subtle linguistic markers suggesting account compromise or fake personas, track the spread of narratives across platforms, and even predict emerging threats based on discussion trends. Capabilities that proved crucial during events like the Arab Spring or recent global elections for understanding information operations in near real time. For corporate security teams, AI-driven SOCMINT tools monitor brand mentions across platforms, flagging potential executive threats, leaked intellectual property, or early signs of coordinated smear campaigns. The dark web presents another frontier where AI enhances traditional OSINT methods. Specialized crawlers and classifiers are able to navigate Tor hidden services and encrypted channels to identify leaked credentials, zero-day exploits, or discussions about impending attacks. They then prioritize findings based on credibility and potential impact. Advanced language models trained on hacker jargon and technical documentation can pass through obscure forum posts to extract meaningful threat intelligence. They recognize when apparently benign discussions about software vulnerabilities actually contain coded references to active exploitation. Geospatial intelligence, or GEOINT, has similarly benefited from AI integration. Machine learning algorithms analyze satellite and aerial imagery to detect construction patterns, track military movements, or monitor environmental changes, tasks that previously required teams of imagery analysts. Commercial tools now combine this capability with social media check-ins and geotagged posts to create comprehensive pictures of physical locations. This is useful for everything from disaster response to supply chain verification. The legal and ethical use of these technologies remains paramount. Responsible OSINT practitioners implement strict protocols to ensure compliance with data protection regulations like GDPR. They also maintain methodological transparency that allows findings to withstand scrutiny in court or boardroom settings. AI's most significant contribution to OSINT may lie in its ability to overcome information overload, the perennial challenge of filtering signal from noise in an era of exponential data growth. Machine learning classifiers automatically categorize and prioritize incoming information, while summarization algorithms distill lengthy documents to their essential points, allowing human analysts to focus their limited attention on the most relevant material. However, these capabilities come with substantial risks if deployed without proper safeguards. AI systems can inadvertently amplify biases present in training data, make incorrect connections based on superficial correlations, or violate privacy norms when scraping personal information. The most effective AI OSINT workflows maintain human oversight at critical decision points, combining algorithmic processing with expert judgment to validate findings and contextualize results. As the technology matures, we're seeing the emergence of multimodal AI systems that can simultaneously process text, images, video, and network data to build comprehensive intelligence pictures, like identifying a protest's organizers by correlating social media posts with live stream footage and transportation data showing unusual movement patterns. These advanced capabilities are reshaping fields from journalism to law enforcement, but they also raise important questions about privacy, consent, and the appropriate boundaries of public information gathering in democratic societies. The future of AI in OSINT points toward even more sophisticated applications: real-time multilingual analysis during crisis events, deepfake detection at scale, predictive modeling of security threats based on socio-economic indicators, all while grappling with the fundamental tension between powerful intelligence capabilities and the ethical responsibility that comes with them. What remains constant is that AI serves best as a force multiplier for human investigators, rather than a replacement, enhancing our innate pattern recognition and analytical abilities, while we provide the contextual understanding, ethical framework, and strategic direction that machines cannot replicate. The organizations that will derive the most value from AI OSINT are those that view the technology as enhancing rather than replacing human expertise, creating collaborative systems where each complements the other's strengths while mitigating their respective weaknesses in the relentless pursuit of actionable intelligence from the vast ocean of publicly available data.